graphical representation of a linear motion. Yeah, other students listen carefully. There is a different types of graphs may be considered further. First one is about the displacement and time graph. First one is displacement time graph. Next concept, velocity time graph. After this, acceleration time graph. Yes, I hope you got it here. There is a displacement time graph there here, velocity time graph is there here, acceleration and time graph is there here. There are different types of graphs are there here. This is called a DT graph. This is called a VT graph also. And this is called AT graph also. Sometimes it's a acceleration graph also. Yes, for the drawing the graphs for any motion, we want to represent any graphical representation for any types of motion. We have to should take what is on x-axis and what is on a y-axis. Actually, there is this displacement and velocity and as well as the accelerations are maybe depending on the time only we are considering. That is why every time for maintaining of the graphical representation purpose, we are taken axis now. There is an x-axis. Most probably on x-axis we are taken a time. Okay, clear? For our easy representation purpose, we are taken most of the graphs containing what? Most of the graphs are containing t is on x-axis, time is on x-axis, and it is on y-axis. What is on y-axis? Either displacement or velocity or acceleration. It is on time. It is on what? It is on y-axis. Got it or not? Yes. And that is only first fundamental concept you have to know. Yes. What is that? Time is on y-axis. Yes. And whatever the changes are coming in either displacement or velocity on y-axis. Yes, we have to take them. Yes, here these graphs gives what the information for us. What the information that gives for us the graphs here. Yes, what the information are gives here for us. Yes, the graphs are very useful. Yes, for studying the linear motion of the body when we take that is a displacement graph. And these graphs are find the slope of the graph also, and that may equal to what? Displacement by time. Okay, clear or not? Suppose you take here, this is the what we are taking, it is the displacement on the y-axis. Displacement we are taking on where? On a y-axis. Time is on what? Time is on x-axis. Okay, clear? Yeah, first now we are going to discuss about this displacement graph clearly. Okay, there is a different types of displacement and time graphs are there. Especially the displacement and time graph is what is the use of it? It will be clearly given about the linear motion. Okay, now and the fundamental ideas are great for us. Why? Because the motion are steady. The first start from where? First start from change of its position from one point to the another point. You know very well, change of its position from one point to another point. The length covered by it is only called what? Or path covered by it is only called distance. In case we given any direction, it is called displacement. Our linear motion is the starting point of our linear motion is what? Displacement or a distance only. This way, it is a fundamentally I give an idea about a what? A fundamental idea is given from this. That is only what? Displacement and as well as the time graph. Okay, now and the next one is about. Suppose you know very well. Yes, when we draw a line, it is a container what a slope. Okay, now. Yes, it is only called what? Slope. The ratio between the y coordinates, difference between y coordinates by the x coordinates, that is only called what? Slope. Okay, now here there it is also given the what? The slope of our displacement graph is a what? Slope of our displacement graph is the displacement by time. It is a what? It is a displacement by time. Slope of the graph is about displacement by time. Okay, you know very well. It is a equal to what? Velocity. Yes, means what? This graph is a gives about the velocity also. It is a gives the information about the velocity also. Understood or not, all the students? It also gives the information about velocity. Yes, and next one it will be most probably we are taken here. Yes, totally there is a totally three types of displacement and time graphs. Okay, now we are going to check that what is the graphs actually. Displacement time graph is the parallel to the time axis. Okay, the first graph is taken as what here? There is a displacement and a time is taken as parallel with one another. At that time, yes, we are taken a what? One graph is like this will be there. It is the time and it is the displacement. Okay, now suppose one line is parallel to the which one? Parallel to the our time axis. It is a called what? It is a called a time axis also. It is a parallel to the time axis. It is indicates what actually. Yes, the body is not changing its position with respect to the time. When the one body is in a steady, okay now, yes, at that time the graph is looks like this. Very, very important. The question may ask for you, yes, further, yes, suppose it will indicate what? It is the first second, it is the second second, it is the third second, it is the fourth second, it is the fifth second. Okay, body in somewhat a position, somewhat a distance is a travel. Okay, now here 0 to the first second, it will be travel somewhat a 5-meter distance, it is a 10-meter distance, it is like that we are considered. Suppose it is taken as yes 2.5, it is a 7.5 meters. The body is not changes, it looks what actually it is what the point is indicate the what 1, 5. The point is indicate the what 2, 5. This point is indicate the what 3, 5. This point is indicate the what 4, 5. This point is indicate the what 5, 5. The y-axis, y component is not changes. Okay, means what? It is steady. With the time, there is no change in the distance. Means what? Means what? It will be steady body. It is not changes. It's a position with respect to time. Understood or not, all the students? This is only gives about our steady position, steady nature of the body. Okay, and next to come to here. Yes, understood or not, all the students? That is the first displacement time graph is parallel to the time axis. It will be indicates our steady position. And next to come to here, yes, displacement time body governing its uniform velocity. And next one it is taken as what? Uniform motion purpose. How to we draw the displacement and the time graph. Uniform motion. When you take a uniform motion, how we write the displacement and time graph? Suppose you have to take here. There it is the graph now, it is the T and as it is the D they are taken on the y-axis. Uniform motion, what it is information gives for us equal time interval, it is traveled equal distances only. That is only called what? Uniform motion. Okay now? Yes. Suppose you take it is the time. It is the traveling distance. It's a traveling distance in a meters. Okay, clear or not all of you? Yes. And it is a 1 second, 4 meters. Okay, now next second should be it is a 8 meters. And where it is again it is the more 4 meters, but the value is at a 8. And next third second it will be traveled which distance it should be, okay, 12. Okay now, and fourth it should be a 16. Okay, that time only it is a called what? At that time only it is a called uniform motion. Otherwise it is not called uniform motion. Yeah, 1 second. Then it is the what we are taking, it is T is equal to first second, T is equal to second second, T is equal to third second. Yes, T is equal to fourth second. Got it? Now, then it is on that one we again taken 4 and as well as the 8 and as well as the 12 and as well as 16 and 8. Yeah, 1 second. How the points are get for us? For 1 second it is a 4 meters. For 2 second it is a 8. For 3 second it is a 12. For 16. 1 second it looks like in a straight line now. Okay, clear or not all the students? Yes, when you take a graph paper, exactly what will we get for us? Yes, it will be get for us. Yeah, 1 second, it looks like in a which form? Straight line form. What you understood from this? What you understood from this? When we are taken a uniform motion, when we are made it is as a uniform motion, at that time there is the graph looks in the form of a straight line. Okay, clear or not all of you? The graph is in the form of a straight line. It is a called what? It is a yes uniform motion. Or in another form, there is a displacement and time graph. Displacement and as well as the time graph is in a straight line form. Okay, now it is a different type of motion. It is a uniform motion. Okay, now in another way, answer the question. Got it? This is the what? Which purpose? Uniform motion. The graph of uniform motion. Yes. And next one. After this, there is we have taken it is yeah. Suppose you have to take us for these values velocities of the okay now. Yes, velocity of this particular body. It is a uniform motion only. It is a contain somewhat velocity. Velocity nothing but change of rate of displacement. Okay now. Now we want to take a slope of this for this between these 2 points. Okay now. Clear or not all this? And here it will become what actually the change between a slope is equal to taken as one. Slope is equal to del d by del t. Okay, clear? Here, what is the point here? 8. And what point here? 12. 12 minus 8 by 3 minus 2. Got it or not? 12 minus 8 by 3 minus 2. The corresponding points are what here? There it is, sorry. It is a 2 and it is a 8. It is a what? 3 and it is a 12. Got it or not? The points here 2 and 8, 3 and 2. Yes, slope is equal to taken as what? Yes, difference between y coordinates by difference between x coordinates. Okay, clear or not? That is only called a slope mathematical. Yes, that is written as y2 minus y1 by x2 minus x1. Okay, clear? This is the called slope. In your maths, it will be there. And here, what is the y2? We are taken 12. And y1 is 8. Like that. In our textbook, they given another problem, 1 second. Now, what is the velocity here? Velocity becomes 4 meter per second. What is the velocity here? 4 meter per second. Got it? Got it or not? Yeah. Your velocity, it is equal to slope. Yes, the concept is important. These pictures and these values are varied. Only the concept is when we are taken, it is a displacement and time graph. Displacement and time graph, it will be in case it is uniform velocity, in case it is uniform velocity, or in case it is rate. Got it? Here, there it is a what we are taking is there is a you have to take this velocity equal to slope. Slope is equal to 12 minus 8 and a 3 minus 2 we are taken 4 meter per second. Okay, now this is okay. It is a velocity we are considered. Got it or not? It is a straight line. It is a called okay uniform motion. Wherever it will be get displacement and time graph is looks like in a straight line manner. It is a called what? It is a called displaced. It is a called what? What it's a called? Uniform motion. Okay, na? This is about a uniform motion. In case it is a non-uniform motion, how the graphs may get first? How the graphs may get first? That is the gets as a curve. Okay, clear or not all the students? When we are taken, it is a non-uniform motion. Yes, we can't say directly. We can't say it is a straight line. Any of the curve. Okay, now may like that it will be get or may like that may get they are may get like that. Okay, why? Because it is a non-uniform. It is not a straight line. It is changes. It's a yes curve nature. Suppose you take it is the x-axis. It is the next one. It is the what? Y-axis. Okay, now on the x-axis we are taken. It is the what? Time. Okay, now what that? 1 second. 2 seconds, 3 seconds, or 4 seconds. Okay, non-uniform means what? Non-uniform means there is a not equal changes are there. We imagined that particular body at 1 second 2 meter distance. At second, it is a 5 meter distance. And third second, it is made at a 9 meter distance. Okay, and the fourth second, it is made antenna 0 distance only, we called, suppose. How the graphs is get? 1 second here, there is I am not taking a graph paper. Yes, just simply I am drawn here. It is a what? First second, second second, third second, and fourth second. Got it? And now I am taking it is the what the values here. Yes, here. There it is a 2, 4, 6, 8, and 10. Understood or not all the students? Here, there it is a 1 second, and suppose may it is 5. Okay, clear or not all the students? Next it is the what? 1 second means it is the water value I am taken 2 meter distance. And it is when it is a 2, I am taking here what? It is May. Okay, clear or not all? And as well as it is a 9 for 3 seconds, it may here. Okay, now and as well as for 4 seconds, it is a no distance, it is there 0. One standard is all the things. How it will be? Got it or not? How the graph is there now? It is not a straight line. It in which form somewhat a curved nature it will be get for us. Understood or not all the students? This is a curve. R may sometimes it's a start like this also. Okay, now we can't expect there is what the type of curve may get, but it is not a straight line. It should be in a curvy manner only we get the curve. Okay, clear or not all of you? Whatever the line it is there, it is a curved manner make it. Okay, clear or not? Displacement time graph in case it is not a straight line. It is not a parallel to the any of the axis. Okay, clear or not, all of you? It is not a changes. It's a axis, any of the axis. It's a parallel to the time axis only. Okay, now yes, it is always at a one straight line. From this one, what we get? What is the nature of the linear motion? Make it first. In case it is a parallel to the time axis, it is a which type of a motion? It is a steady. The body is not changes its position. In case the curve is looks like in a straight line manner, it is a which type of motion? Uniform motion. Okay, now in case the curve is okay, now yes, not it is in a form of a straight line. It is a contain a different nature. Okay, now it is a what? It is a taken as yes non-uniform motion. Got it? I hope you got it. Next. Yeah, after this there is a we are taken about displacement of displacement of a time and graph for that particularly this displacement and as well as the time graph. Till now we are taken about actually what is the nature of its motion. Okay, what is the nature of its motion we are taken. In a second point of view, there is the same graph we are taken for what? For a decreasing and increasing the motion purpose also we are taken it is. Okay, and that is the decreasing actually uniform motion. Okay, now there is no change in that. There is it will gradually either increase or decreases. But when we are taking it is a decreasing, the velocity decreasing, or otherwise it is increasing. How it will be looks? Okay, now that will be we are consider. There is suppose now to take here yes. One particularly we drawn there is a like this. Yes, it is indicate which type of graph. There is a time and space I am taking here. It is indicate which type of a graph I am taking like this. Yes, the velocity is the what? Increasing in manner. Okay, now there is it is a first second, there it is a displacement here. Somewhat a second here. Third second here. Understand all of you? Gradually the curve is in a yes upward form. Okay, now it will be what? It is called increasing. Okay, clear or not all of you? The velocity is increasing. Suppose I am taking somewhat a value here. This is the first second, this is the second second, this is the third second. It is a 5 meters, it is somewhat 10 meters, it is somewhat 12 meters. Okay, 1 second, where suppose it is a point A, it is a point B, it is a point C. Yes, now the velocity at a point A it is a become what? Velocity at a point A it is a 5 meters per second. Okay, clear or not all those? Yes, and as well as velocity at a B it is equal to taken as it is a what we consider there it is taken as somewhat B. Okay, clear or not all of you? A to the B, what is the velocity is there here? Okay, now yes, the slope you have to draw for it. Okay, now curved line now there is a slope you have to draw for it. You get for us what there is a point A to the point B. What is the changes are occur in the displacement? Now there is it will be taken as what? The velocity is equal to it is the first second 2 minus 1. Okay, now and as well as what 10 minus 5. Okay, clear or not? 10 minus 5. It will become 5 meters per second only again will be get for us. Okay. Yes, 5 meters per second. From year to year, may uniform. It looks like in a straight line manner. But when we take a B2 say, again it is non-uniform. It is increasing order only. From year to year, there is the same velocity is there. Okay, the same change is there, same velocity is there. 0 to 1 second, 5 meters. 1 to 2, it is 5. Now once observe B to C. Okay, now what happened B to C? There is a what become velocity now? There it is a what we have considered is 3 minus 2. But here 12 minus 10. It will become 2 by 1. It is become what 2 meters per second. Okay, now yes, the velocity is the changes. but there is it is increasing manner, the velocity is in increasing manner or a decreasing manner. Let us see, there is a velocity somewhat less, but here to here velocity is a increases. Okay, now velocity is the same, but it is a what increasing in manner. Understood or not? All those. There is a what? It is a uniform motion. It is a non-uniform motion, but the velocity is in increasing. Like that, where the velocity is increases, where the velocity decreases, also may find from this particular graphs. Okay, clear or not all of you? Yes, I hope you got it. Any doubt here? Somewhat members are made here sounds. Any doubts? Yeah. Now the velocity, displacement, and time graph are given the what information about the where the velocity decreases and from which point to which point it is the velocity decreases and which point to which point velocity increases. That information is also given by our displacement and as well as the time graph. Got it? Yes, I hope you got it. Yeah. Now the conclusions are given here. And once you can once read the conclusions in the page number 63, the conclusions are there. Okay, na? Yes, and the conclusions once you read it. Next component is the velocity and time graph. Already I have given the conclusions. Okay, now once you read. Next concept is velocity, time graph. Yeah, as this is also the same manner we are considered. Yes, in case it is parallel to the S parallel to the S time axis, it is steady. Suppose I am written in the same manner. It is a steady. No. Okay, clear or not? Velocity and time graph is a written like not steady. It contain already velocity, but it is continuously that will be maintain that velocity. It is a what uniform. Okay, not a steady. Okay, clear or not? That is only we are taking here. Every time it will be maintained about the same velocity. The body is not called as a steady velocity. It is called a uniform velocity. Okay, clear or not, all the students? Suppose I am taken here on x-axis, means what time taken, and velocity I am taken here for 1 second 2 meters. For second also 2 meters. Okay, now it is meters per second. Okay, now third second also 2 meters per second. Fourth second also 2 meters per second. This is a called what? This is a called uniform velocity. The body contains uniform velocity. Why? Then it is I am taken 2, 4 like that. Now there is the first second 2 only, second second 2 only, third second 2 only. Okay, clear or not on this? Yes, this is a called uniform velocity body. Okay, now yes. And now the next, the graph is changes somewhat. Okay, now yes, the given here. Yeah. Next one is given so many graphs here. Okay, now yes, there is a figure one. It is a represents about velocity time graph, and body starts from rest and velocity increases in a uniform rate. Okay, clear or not? Yes, and suppose the given the components are like that. Yes, at the 0 second it is the 0 only. But at first it is a 4 meters and one is 8 and moreover yes third second it is a 12, fourth second it is a 60. Okay, now the graph is here. How will we get? You know very well already. The graph is not changes. It is a velocity. It is a time. Understood all of you? The velocity it is nothing but what actually. Then it is a 1 second. It is a 2 seconds. It is a 3 seconds, and it will be moves in a what? Start from where? From rest here. 0 and 0 means what? It is a rest. and the rest to do it will be 4 meters per second velocity, and as well as next what 8 meters per second velocity, and as well as next what it is 12 meters per second velocity. As second to second the velocity is increases, but equally it is increases. That's it. When there is a equally there is a change in a velocity is occur, that is also gives the what straight line. Okay, now that is the gives the straight line. Understand all of you? It's indicates actually uniform acceleration. Okay, like whatever we are taken a slope in a displacement and time graph, that will give what velocity. Here slope in a velocity and time graph, yes, it will be used for us acceleration. Okay, now it will be give the what velocity by time. It gives the what acceleration. This is indicate the what uniform acceleration and equal change in a velocity. Equal change in a velocity. It is understood or not? And there is a figure B is a given. Okay, now yes, figure 2 it is a given part. Yes. And we started here like that. Suppose the same graph here be taken. The graph we are taken, it is like that. It is a velocity and as well as it is a time. Okay, clear or not on this? And taken it is a what? Velocity is at here and time is at here. Now at the 0 second, okay, now this time when it is a not 0 and 5 means what? It's already in a moving body. We taken a graph for what? The meaning is what? The 0 second. There is no 0 second. The time is there. Okay, now yes, when we are not considered at that time only, the meaning of it what actually when we are not seen at that time when it is the start. Okay, clear or not? At that time we taken the graph like that. At 0 second only when we observe at the time of 5 meters, then after again it will be what indicates. Yes, it will be again equally it will be changes its velocity. Time to time equally changes its velocity. It's not at rest. The what is the difference between these two graphs? Yes, it's a start from rest. There is no velocity at this particular point. Start from rest and moving with some velocity. It is a what? It is a not at rest. It will be already contain some velocity. Yes, it already contains some velocity. It is moving only, but equally changes its velocity. Okay, now equally changes its velocity. Got it? Yeah. This is only about what? This is only about. Okay, now yes, our velocity and the time graph. Sometimes there is a zigzag. Okay, now that time there is a velocity that changes time to time, not in order. In orderly, the velocity changes. Sometimes increases, sometimes increases. Clear? That graphs are also there. That is the velocity changes. Yes, not in a same manner. Here, same manner. Yes, same change in a velocity. Yes, but it is a start from rest. It is a start from. Okay, now yes, motion. Got it? Already it is in under motion. Okay, clear or not? Like that, the graphs are have the difference. Tomorrow we'll go with discussion with the somewhat other graphs. That is acceleration and time graph. Then we are going with the yes, somewhat exercise problems. Okay, now thank you, students. Yes, bye. Take care and conclude that whatever the synopsis they given in our textbook in a page number 63. Okay. Yes. Yes.